A very good day to my SV, Dr. Mimi, and my co-SV, ENCIK MUHAMAD FAIZ, and my panel. My name is Zhen, and today I would like to give a presentation about my FYP thesis report. My FYP thesis report title is The Development of Anti-Collision System for Mobile Crane During Lifting Operation. For the introduction of my project, I would like to start with background of study. First, let me introduce what is crane. Crane is a complicated piece of machinery that made up of multiple rigid bodies connected by different types of joints. All the crane parts such as the main boom, jibs, upper swing platform, and hooks works independently. Crane is one of the most important and widely used equipment for lifting. Although cranes are very useful equipment that used to help to transport the load, crane considered as one of the major causes of fatalities on construction sites. Based on the record, there were about 1,125 crane accidents recorded worldwide from 2000 to 2010. And mobile cranes and truck cranes are associated with 78% of crane-related fatalities in the United States. Furthermore, being struck by a crane or a crane part became the third leading cause of fatalities. Is problem statement part. The first problem that found is the safe distance between the crane and the obstacle is estimated by the signal or operator itself by the method of visual. This method usually causes errors and causes a great potential danger in the work of the field. Next, the working environment of mobile crane often congested with different kinds of obstacles. This obstacle introduce a lot of blind spots during lifting operation and cause the loss of visibility and make it difficult for the crane operator to make accurate judgment. Moreover, due to there is no special anti-collision system on the crane, the obstacle cannot be detected and the crane will not automatically stop itself when the crane was close to the obstacle and can lead to accidents that could potentially cause injuries or fatalities. The first objective of this study is to design a safety system that uses proximity sensor to detect the obstacle in the blind spot area and provide assistance to the crane operator during lifting operation. The next objective is to develop an anti-collision system with a high response rate automatic stop function that can keep the crane have a safe distance from the obstacle. The third objective is to determine the performance of the anti-collision system by conducting an evaluation. Next, let me proceed to methodology part. The flowchart on the right is the flowchart of this project. Next is the hardware design part. First, let me introduce the hardware used to construct the anti-collision system module. For anti-collision system module, Arduino Mega is selected as the microcontroller platform. Next, the laser transmitter module and laser receiver module are used to create a laser trooping sensor to detect the obstacle around the main boom of the mobile crane. While the ultrasonic sensor is selected to attach to the main boom head of the prototype mobile crane to detect the obstacle around the main boom head. Next, the infrared sensors are selected to attach on the left side and the right side of the upper swing platform of prototype mobile crane. Lastly, LED and buzzer also used to construct the anti-collision system. The buzzer is used to alert the crane operator when the crane is close to the obstacle. Lastly, the LED were used to light up and to alert the crane operator when the crane is close to obstacle and let the operator know the position of the obstacle. Next, the diagram below it shows the position of sensor on the prototype mobile crane. In this project, 4 sets of laser transmitter and laser receiver are installed opposite to each other to enable the laser light from the transmitter enter the receiver. This mechanism is called as laser true beam sensor. These 4 sets of laser transmitter and receiver is placed at upper side, lower side, and left and right side of the main boom. The laser beam around the main boom can use to detect the obstacle when the obstacle interrupts the laser beam between the transmitter and the receiver. Next, the ultrasonic sensor is attached on the main boom head of the crane to detect the obstacle around the main boom head, while the IR sensor, which is the infrared sensor, is attached on both sides of the steering platform to detect the obstacle around the steering platform. Next is the hardware design for prototype control system module. Microcontroller, motor driver, motor and joystick module were used to construct the prototype control system module. Arduino Mega is used as the microcontroller platform. The motor driver module acts as the interface between the motors and the prototype control system, and it is used to control the motor. The dual-axis gear motor is used to move all the parts of the telescopic mobile crane prototype, while the dual-axis joystick module let the user control all the parts of the telescopic mobile crane prototype. And next, this is the schematic diagram of the anti-collision system and the prototype control system circuit. Next, let me proceed to the coding part. In this project, Arduino IDE software is used to develop the coding of the anti-collision system and prototype control system. For anti-collision system, a set of coding is designed so the alarm can be triggered if the crane is close to the obstacle. If there was any obstacle was detected by the sensor, the buzzer will sound and the specific LED will light up. Next, for the prototype control system, a set of coding is designed so the user can control the movement of the telescopic mobile crane prototype by using joystick. If the joystick is being moved, the motor driver will control the specific motor to control the different parts of the telescopic mobile crane prototype. After the coding is being constructed, the user can use the joystick to control the movement of the mobile crane prototype. The prototype control system mechanism is shown at the sketch diagram above. Next is the system flowchart. The crane can be moved after the system starts. When the crane is moving, the system will detect the obstacle. If there was no obstacle, the crane will continue to move. On the other hand, if there was obstacle is being detected by the system will stop the crane. Then the buzzer will release sounds and the LED will light up. Then the crane will be moved away from obstacle. After that, the system will proceed to the loop where it starts with detection of obstacle. Once the system circuit and coding has been constructed, the next approach is to construct the telescopic mobile crane prototype, so the anti-collision system can be attached on the prototype. To construct the prototype, square PVC pipe, wooden bob, dual-axis gear motor, and the circular rack and pinion gear set is being used. And here is the sketch diagram of the telescopic boom mobile crane prototype by using the material that have listed previously. The two-section telescopic main boom is constructed by square PVC pipe, while the motor and a set of rack and pinion gear will be used to control the boom section move outward or inward. While the dual-axis gear motor is used to construct the linear actuator, and the linear actuator is used to control the main boom move upward or downward. The wooden bob is selected to construct the prototype upper steering platform, and a set of circular rack and pinion gear is used to construct the steering gear of the prototype. Once the anti-collision system and prototype control system have been completely constructed, the next approach is to evaluate the performance and effectiveness of the circuit and system. This methodology part aims to meet the third objective of this research, in which the performance of the anti-collision system will be evaluated. The testing and evaluation for the constructed circuits and coding is conducted in order to ensure the anti-collision system module and prototype control system module can perform in a well manner. A few parameters will be examined, which include the detection range of the proximity sensor, the detection ability on different size of obstacle, the detection ability on different type of material, and the successful rate of the automatic stop function. Next is the preliminary result of this project. So this is the prototype control system module. It consists of a Arduino board, 3 motor, 2 motor driver, and 2 joystick. When this left joystick is moved forward, this motor will be moved, and this motor is to control the main boom actuator, so the main boom can be moved upward or downward. If this left joystick is being pushed to the left or right, this motor will be moved, and this motor is actually to control the upper swing platform to rotate to clockwise or anti-clockwise direction. And the joystick at the right side is to control the boom section, move outward or inward. This motor is to control the boom section to move outward or inward. So this is the control mechanism. And this one is the anti-collision system module. So this one is the laser through beam sensor. When there is obstacle interrupt the laser beam, the buzzer will sound and the LED will light up. For the other sensor, the concept is also the same. Like this, the infrared sensor, when there is obstacle, the LED will light up and the buzzer will sound. Let me proceed to the expected result of this project. In the end of this project, it is expected by using proximity sensor, a safety system is successfully designed that can detect the obstacle in the blind spot area and can provide assistance to the crane operator during lifting operation. Next, it is expected an anti-collision system is being developed with a high response rate automatic stop function that can keep the crane have a safe distance from the obstacle. Lastly, the performance of the anti-collision system is expected to perform well by conducting an evaluation. And that's all for my presentation. Thank you.